Every U.S. Space Shuttle was built around the same flaw, and NASA knew about it before Columbia ever left the pad. 6 were built. 5 of them flew. 2 came apart, 1 on the way up, 1 on the way down. But the flaw wasn't the foam. It wasn't the rubber seal either. It was written into the design in 1972, before a single piece of metal was cut. And by the time Atlantis rolled to a stop for the last time, that decision had cost 14 lives. I went through all 135 missions of the program, the 5 volumes of the Rogers Commission report, and the 6 volumes of the CAIB report to put this in order. 6 ships, 135 missions. Hubble, the space station, roughly $1.5 billion a launch, for a vehicle that was supposed to cost $20 million. The shuttle is remembered as the machine that made spaceflight routine. But it was one of the most dangerous crewed vehicles ever flown on a regular schedule. And the safest one in the fleet is the only one that never left the atmosphere. Let's start with something that doesn't ADD up. The orbiters are numbered. Columbia is OV-102, Discovery 103, Atlantis 104, Endeavour 105. A clean run. But Challenger is OV-099, a lower number than any of them. And it isn't a typo. It's the first clue to how this program actually worked, on the fly, with whatever parts were lying around. 099 wasn't born to fly. It was born as STA-099, a structural test article. A complete airframe that Rockwell handed over to be tortured. 11 months of vibration testing in a 43-ton steel rig. 256 hydraulic jacks, spread across 836 load points, simulating launch, orbit, re-entry, and landing. The plan was different. The second operational orbiter was supposed to be Enterprise, OV-101. But Enterprise had no working propulsion system, no thermal protection, no life support, and most of its cockpit instrumentation was missing. Converting it was judged too hard, too slow, and too expensive. So, in January 1979, NASA did the unthinkable. It signed a contract to turn the test rig into a spacecraft. Nobody ever went back and fixed the number. The designation simply froze in place, even as the plan changed underneath them. The names have a logic of their own, and it's a nautical one. Every orbiter is named after a ship that pushed a frontier at sea. Columbia, the small sailing vessel that left Boston in 1792 and explored the mouth of the Columbia River. Challenger, the British research ship that crisscrossed the Atlantic and Pacific in the 1870s. Discovery and Endeavour, 2 of James Cook's ships. And Atlantis, a modest 2-masted ketch that spent decades doing ocean research out of Woods Hole. Enterprise was supposed to be called Constitution for the bicentennial. But hundreds of thousands of letters arrived from Star Trek fans, and President Ford ordered the name changed. He said he was partial to it. The day they rolled her out of the hangar at Palmdale in September 1976, the cast of the show was standing there. One thing before we go on. This list doesn't include Pathfinder, a steel and wood mock-up, never officially numbered, built to check whether an orbiter would fit through the doors and under the cranes. It doesn't include Independence, a museum replica, and it doesn't include OV-106, a set of structural spares whose contract was canceled before anyone finished them. None of them flew. None of them were ships. We'll take these in order of service, with one exception. Atlantis goes last. By the end, you'll understand why she had to. Because Challenger's strange number isn't the only scar 1972 left on this fleet. It's by far the smallest. On January 5, 1972, Nixon approved the shuttle, but he approved it with the wallet half closed. about $5.15 billion to develop it, a target of $20 million a flight, and a promise of up to 50 launches a year. On that budget, NASA couldn't build it alone. It needed a partner with money. So, it went to the AIR Force, and the Air Force named its price. They wanted a payload bay 60 feet long and 15 across, big enough to swallow a spy satellite. They wanted 65,000 pounds to orbit. And they wanted something far more awkward, cross-range, 1,100 nautical miles of it. The idea was to launch from California, make a single polar orbit, and come straight home. But in that hour, the Earth would rotate underneath the ship, and the landing site would end up more than 1,000 miles away. To reach it, the orbiter would have to glide hypersonically, cutting sideways through the atmosphere. And that's where the simple design died. Max Fegget, the lead engineer, wanted a straight wing. Cheap, light, nose high on re-entry, relatively cool, but a straight wing gives you no cross range. So, in came the delta wing, more surface area, more lift, less drag, and heat that was both hotter and lasted longer. Thousands of thermal tiles where there might have been hundreds. The enormous bay then ate the internal fuel volume. So the propellant moved outside into a throwaway tank. Liquid boosters, the kind you can shut down, were too expensive and too complex. So they went with solids, cheaper, faster, inherited from the Titan III. And a solid rocket, once you light it, cannot be turned off. And since the crew had nowhere else to sit, they ended up bolted to the side of that tank, directly in the path of anything that fell off it. With no escape system. That's the villain of this story. Not a man, an equation. And the solids brought a time bomb of their own. They were cast in Utah, shipped in sections, and assembled in Florida. The joints between segments were sealed with 2 rubber rings. In November 1981, after the second flight of the program, engineers pulled the boosters apart and found the primary seal eaten away. 0.05 of an inch, chewed through by hot gas. They didn't fix it. They reclassified it. Criticality 1. A failure there means the loss of the orbiter. And still, nobody grounded the fleet. 20 million a flight, they said. The real figure would end up somewhere around 1.5 billion. 50 flights a year, they said. There would be 135 in 30 years. But before any of these machines went up, NASA had to prove something basic, that a 75-ton wing brick could land without engines. And to find out, they built a shuttle with no engines at all. That engineless shuttle is OV-101, Enterprise, and she is the only one of the 6 that never left the atmosphere. She could not. Enterprise had no working propulsion, no thermal protection, no life support. Where the 3 main engine bells belonged, there was a tail cone. The cockpit had 2 seats, and not much else. She was, in the most literal sense, a mock-up that flew, which was exactly the point. Because NASA had a question no computer of the era could answer: can a 75-ton glider, with no engine and exactly 1 shot at the runway, actually be flown by a human being? Between February and October of 1977, out at Edwards, they ran 16 trials, taxi tests, captive flights riding on the back of a modified Boeing 747, and 5 free flights. The first was August 12th. At the controls, Fred Hayes, the same man who, in 1970, had been sitting inside the lunar module of Apollo 13, going around the moon in a crippled spacecraft. Explosive bolts released Enterprise at around 20,000 feet. She glided for 5 minutes and 21 seconds, and she settled onto the dry lake bed. For the last 2 flights, they pulled the tail cone off and bolted on dummy engines, dead weight, purely to copy the aerodynamics of a ship coming home from orbit. Then came the plans to turn her into a real orbiter, But you already know how that ends. It was cheaper to rebuild the test rig. So, Enterprise stayed on the ground forever. And here is the part almost nobody tells you. In 2003, when investigators needed to prove that a chunk of FOAM could tear a hole in a wing, they needed real orbiter hardware to shoot at. They used a landing gear door from Enterprise. And part of her left wing, the one ship that never flew, ended up explaining why Columbia did not come home. And Columbia is next. Columbia was first, which is why she was the heaviest. She carried miles of instrumentation wiring the others would never need. Ejection seats, sensors everywhere. Around 3.5 extra tons. That weight would decide her entire career, though in 1981, nobody was thinking about that. In 1981, the question was simpler, whether the thing was going to kill the 2 men strapped inside it. On April 12, 1981, Columbia lifted off with John Young and Bob Crippen aboard. And it's worth stopping here, because this gets skipped. No brand new spacecraft had ever flown crewed on its first flight. Not Mercury, not Gemini, not Apollo. Every one of them was tested empty first. The shuttle couldn't be. With no engines on re-entry, somebody had to land it. So, the test flight and the crewed flight became the same flight. Young had already walked on the moon. Crippen had never been to space at all. They went up. They went around the Earth 36 times, and they came back. What they didn't know is that at ignition, the overpressure wave from the solid boosters had torn 16 thermal tiles off their spacecraft and damaged 148 more. They found out after they landed. The first ship of the program had come home, leaving pieces of its heat shield on the launch pad. Nobody called that a pattern yet. Columbia kept flying, but her weight locked her into a supporting role. She was too heavy to carry useful cargo to the space station's orbit. So, she became the fleet's laboratory. The Space Lab module, microgravity research, long-duration science. And in 1999, she launched the Chandra X-ray Observatory, the heaviest payload a shuttle ever deployed, on a mission commanded by Eileen Collins, the first woman to command a space shuttle. Her 28th mission was STS-107, January 16, 2003, a 16-day science flight. At 81.7 seconds into the ascent, a piece of insulating foam broke off the left bipod ramp of the external tank. Roughly 2 feet across, it fell, struck the leading edge of the left wing at around 500 miles an hour, and punched a breach in the carbon panels. That foam had been shedding for years. Pieces had come off that same ramp in 1983, in 1988, in 1990, in 1992. But the program didn't treat it as something to fix. It reclassified it as an accepted risk, which is exactly what had been done with the booster joints. For 16 days, neither the crew nor the ground knew there was a hole in the wing. On February 1st, Columbia hit the atmosphere. Gas at more than 3,000 degrees Fahrenheit poured through that breach and began eating the wing from the inside. She broke apart over Texas at Mach 18, 7 people. The CAIB was blunt. The physical causes and the organizational causes carried equal weight. The foam took down the wing, but the wing had been flying for 22 years under a design that put the crew directly beneath a shower of falling debris. The foam didn't decide that. That was decided in 1972, although by then the program had already been taught this lesson, 17 years earlier, by the ship that was never supposed to fly at all. Challenger arrived in Florida in July 1982 as, on paper, a second-hand vehicle, the test rig NASA had chosen to rebuild rather than convert Enterprise. She turned out to be better than the ship she was replacing. Everything learned on Columbia went into her. Fewer tiles, more white insulation blankets in the cooler zones. Around 2,500 pounds more payload. She was the first orbiter with a head-up display for landing. She flew for the first time on April 4th, 1983, and within 2 years she was the workhorse of the fleet. In 1983 and 1984, she flew 85% of all shuttle missions. And almost everything you picture when you picture the shuttle happened in her payload bay. The program's first spacewalk, on her maiden flight. The first American woman in space, Sally Ride, in June 1983. The first African-American astronaut, Guian Blue Ford, 2 months later. The first night launch. The first landing in Florida. And in February 1984, the image that defined the decade. Bruce McCandless floating untethered, hundreds of feet from the ship, with a jetpack on his back and nothing else. Challenger made space look easy. That was the problem. On January 28, 1986, the Cape woke up below freezing. There were icicles hanging off the service tower. The coldest launch before that had been at 53 degrees, and those joints had shown the worst gas blow-by ever recorded. The night before, there was a teleconference. Engineers at the booster contractor recommended not launching below 53 degrees. The rubber stiffens in the cold and does not seal in time. They were heard, and then they were overruled by their own management. Challenger lifted off at 11:38. 73 seconds later, the lower joint on the right-hand booster, the same joint that had been eroding since 1981, let a flame through. That flame cut the booster's attachment strut and burned into the external tank. And here it is worth being precise, because almost everyone gets this wrong. It was not an explosion. The tank disintegrated, the stack swung out of its flight angle, and the orbiter, moving at nearly twice the speed of sound, was torn apart by aerodynamic forces, like an aircraft pulled to pieces by the air. The crew compartment separated intact. At least 3 of the 4 emergency air packs recovered had been switched on by hand. Somebody in there kept working. The cabin fell for 2 minutes and 45 seconds. There was no escape system. There never had been. That was decided in 1972. 7 people died, among them Krista McAuliffe, a high school teacher from New Hampshire. Millions of school children were watching live, in class. The Rogers Commission found 2 things. That the joint failure came down to a faulty design, and that the decision to launch was flawed, made by people who did not know the history of problems with those seals. And a physicist on the commission, Richard Feynman, proved it on camera with a glass of ice water and a piece of that rubber. Pulled from the ice, the material did not spring back, a $5 experiment explaining a multi-billion-dollar catastrophe. Challenger flew 10 missions. She was the only orbiter that never wore NASA's classic round insignia. The fleet sat on the ground for 2.5 years, and when it finally flew again, it did not fly on a new ship. It flew on the one that was already there, waiting. When NASA needed someone to fly again, it didn't pick a new ship. It picked Discovery, twice. Discovery reached Florida in November 1983 and first flew in August 1984. She got the benefit of everything learned on the 2 before her. Cleaner construction methods, a lighter structure, blankets instead of tiles wherever the heat allowed. She was the lightest of the first 3, so she could carry the most. And she ended up going up more than any of them. 39 missions, more than any other spacecraft in history. On April 24, 1990, she opened her payload doors and released an 11-ton tube, the Hubble Space Telescope. Then came the humiliation. The first images came back blurred. The primary mirror had been ground wrong. The most expensive telescope ever built was short-sighted. But, and this is the one genuine advantage the shuttle had over any rocket ever made, NASA could go back. In 1993, A crew flew up and fitted corrective optics. Discovery herself would return to service the telescope in 1997 and again in 1999. No other machine in history could do that. Her most important role, though, was a different one. On September 29, 1988, 2 years and 8 months after Challenger, Discovery launched on STS-26 with redesigned booster joints, 3 extra inches of steel around the seal, and put the program back in the air. And in July 2005, 2.5 years after Columbia, she did it again. STS-114 was returned to flight number 2, cameras all over the vehicle, a sensor boom to inspect the heat shield in orbit, repair kits on board, and on the way up, a chunk of foam came off the tank. It missed the ship, but it was a piece weighing nearly a pound, shed from the same kind of aerodynamic ramp they had been watching for years. After 2 accidents, 14 dead and 2 federal investigations, the tank was still shedding foam. The fleet was grounded again. That's the villain sticking its head up for the 3rd time. It wasn't the rubber. It wasn't the foam. It was the architecture. Discovery also took John Glenn back to space in 1998, age 77, 36 years after his Mercury orbit. And in 1995, she was the first to rendezvous with the Russian station Mir, piloted by Eileen Collins, the first woman to fly a shuttle. She flew for the last time in March 2011, and today she sits in the Smithsonian's Udvar Hazy hangar with her re-entry scorching untouched. They never cleaned her. She is exactly as she came back. Discovery was the ship you called when trust had to be rebuilt. But there's one that wouldn't exist if trust hadn't been broken first. Endeavour exists because Challenger doesn't. When the fleet was built, Rockwell manufactured sets of structural spares, an aft fuselage, half a mid-body, forward fuselage halves, wings, loose parts stored in case a ship was ever badly damaged. So when Congress authorized a replacement orbiter on August 1, 1987, nobody started from scratch. They assembled a shuttle out of her sister's spare parts. And for the first time, Washington didn't pick the name. School children did. A nationwide student competition named her Endeavour, after the ship James Cook sailed in 1768 toward Tahiti to observe the transit of Venus. British spelling, the extra U. NASA kept it. She arrived in Florida in May 1991 and launched for the first time on May 7, 1992. Her maiden mission, STS-49, is one of the strangest of the program. A stranded communications satellite, Intelsat 6, had to be captured and restarted. The astronauts went out with a capture bar. It failed. They went out again. It failed again. So, they improvised something that was in no manual. They put 3 astronauts out of the airlock at once, arms braced, and grabbed a 7-ton satellite with their hands. It remained the only 3-person spacewalk ever performed. Endeavour was born with the upgrades built in, a drag chute in the tail, updated avionics, and the plumbing for long-duration flights of up to 4 weeks. In December 1993, she flew up to fix Hubble. It was Endeavour, not Discovery, that installed the corrective optics that gave the telescope its sight back. And in December 1998, she carried the Unity module and mated it to Russia's Zarya, the first assembly flight of the International Space Station. The first 2 bricks. She flew 25 missions. Her last, in May 2011, left a particle detector on the station. Today, she's in Los Angeles. The ship, built from spare parts, ended up assembling the largest structure humanity has ever put in orbit. One left, and it isn't the youngest or the one that flew the most. It's simply the one that turned out the lights. Atlantis arrived in April 1985. Her first flight on October 3rd was a classified Department of Defense mission. No announced payload, No open comms, no confirmed launch time until the last minute. She was the orbiter that did the most work for the military. She was also the one that looked furthest out. In 1989, she launched the Magellan probe toward Venus, and months later, Galileo toward Jupiter. And in June 1995, she did something that would have sounded insane in 1985. She docked with the Russian space station Mir. Atlantis flew 7 of the Mir docking missions. Ship built for the Cold War became the bridge that closed it. But her most revealing mission is STS-125, May 2009, the final Hubble servicing flight. After Columbia, NASA imposed a rule. Every mission had to be able to reach the space station and use it as a shelter if the heat shield came back damaged. But Hubble is not in that orbit. There is no shelter. So to fly that mission at all, NASA had to do something it hadn't done in years. Prepare a second shuttle, Endeavour, on the other pad, fueled, stacked, ready to launch within days, and pull the crew off. 2 ships, 2 pads, because the first one had no way out. That isn't trivia. That's the 1972 flaw, made visible. And so we come to July 8th, 2011, STS-135. Atlantis lifted off with 4 people aboard: Chris Ferguson, Doug Hurley, Sandy Magnus, and Rex Walheim. The smallest crew since 1983. Why only 4? Because there was nobody left to come and get them. This was the last flight. There was no second shuttle on the other pad. If Atlantis came back damaged, those 4 would move into the space station and come home one at a time on Russian Soyuz capsules over roughly a year. 4 was the number the station could absorb. The final shuttle crew wasn't sized by the science or the cargo. It was sized by a design flaw that had been aboard for 39 years. On July 21, 2011, at 5:57 in the morning, Atlantis touched down in Florida in the dark. As she stopped, Ferguson said 2 words: "We'll stop." And here's the number that changes everything. Before Challenger, NASA management stated the odds of a catastrophic accident at 1 in 100,000. Feynman went and asked the engineers, and they told him 1 in 100. And in 2011, a retrospective risk assessment by NASA itself calculated that the first 9 flights carried a roughly 1 in 9 chance of losing the vehicle and its crew. 1 in 9. That was always the deal, even if nobody said it out loud. The final tally, 2 losses in 135 flights, wasn't bad luck. It was the arithmetic of a machine that carried 7 people bolted to the side of an explosive tank, on top of 2 rockets that can't be shut off, with no way to get out. The shuttle was never the cheap routine vehicle it was sold as in 1972. It was an experimental spacecraft. They flew it 135 times. That's why Atlantis had to go last. She didn't close the program. She buried it. Today, Discovery sits in the Smithsonian, Endeavour in Los Angeles, Enterprise on an aircraft carrier moored in New York, and Atlantis is in Florida, displayed with her payload doors open and her nose up, in the attitude she held in orbit, about 7 miles from the pad she launched from. She's facing the sea, looking out at somewhere she's never going back to. Right now, as you're watching this, there's a shuttle in orbit. It's a quarter the size of Atlantis. Nobody's inside it. It launches on a rocket, lands on a runway like an airplane, and it can stay up there for more than 2 years at a stretch. What it actually does is classified. It's called the X-37B, and it's no accident. It's the last link in a family of aircraft that started by breaking the sound barrier and ended up flying to space in secret. That whole story, X1 to X-37, is right here. Go!